Hi, and welcome to part two of designing and creating a Native American flute using Fusion 360 and your CNC. Let's jump right in. So, as I stated in part one, I'm not going to redo this whole design. It would take forever. I'm going to back up my timeline here and step through everything I did to create this flute. I start by defining the simple shape of my flute, well, of my stock anyway. A rectangle that is overall width in one diameter and total length in the other. Simple rectangle, and then extrude that. And we're going to extrude it to half the width of the flute, which is overall width divided by 2, because the flute is basically a mirror of two sides. We're gonna design one side, and then we're gonna mirror it to create the final flute. My next sketch is just adding a center line. This could easily have been added to that first sketch. I'm not really certain why I did a separate sketch for it. It must have been an afterthought. I decided I needed it, and I just popped up a new sketch and put the center line in. So that's that. My next sketch is the north end of the flute, where the blowhole goes. So if you remember, the north end of the flute is the mouthpiece side. The south end of the flute is the opening at the end of the sound chamber. I'm going to turn off bodies for a minute and find my thing here. Anyway, so what we've drawn on here is a rectangular box representing the half flute. We need that rectangle because we need these two corners to use as a cutting edge to do a cutting extrude to make the round shape. We have an inner radius arc that is the overall width, which is the outside diameter of the flute. We have another arc that is the diameter of the bore, so the inside diameter of the flute. And final, where's that radius? Is that here? Yeah. For the blowhole. So it's the blowhole diameter divided by 2, because we specified a radius here instead of diameter. The width of this is the overall width, and again the height is overall width divided by 2. So we have that finished. First thing we'll do is extrude the blowhole. So it's a negative blowhole length to extrude that. Then I'm going to put a plane in here, an offset plane, to the end of that blowhole, which is the beginning of the slow air chamber. I'm going to need that in a little bit to cut in a space so that I can get a joint on this surface to put in my cutting tool. That'll make sense when I get there in a minute. Let's turn off that plane for a minute. My next sketch is on that plane, and it's just a let's turn the bodies off here, projection of the inner diameter of the flute and the outside box so that I can extrude this space that I'm going to need. And my next sketch is the nest. Let's flip this over and do that. So the nest is going to create a flat top. So it's going to extrude out from the sides. And it's basically just two arcs. They're equal, both radius 1/8 inch. The top surface is what I use my nest length to create the flat surface. So the flat surface on the top is 3. And then I add these two 1/8 arcs to create a nice contour to the nest out at the far edges. You see that in the next thing here when I do my extrude on that. My next sketch would be the south end to define, again, it's pretty much the same as the mouth side, except it doesn't have the blowhole, because all I need this to extrude the inside bore. This rectangle on the outside, just ignore that, pretend that doesn't exist. That has to do with the inlay that we've deleted. In fact, I'll just delete it here. Finish sketch. And hopefully I didn't break anything. Next thing I'm going to do is this extrude is to cut the shape, the outside shape of the flute. So I've selected, let's get it on the face here, these two outside corners, and just extruded it for the I got kind of a complicated thing in here right now. Really, it just needs to be negative total length, because I didn't have that parameter when I did this. So let's just say negative total length. And with that, then we have our outside shape defined. Turn off some of these drawings. Our next extrude is going to be, I believe, is it the nest? Yeah, the nest. So that extrudes out the nest, and you see it gives it a nice little curved shape to it here. Next thing we're going to extrude is the bore chamber. So back up and bore chamber. So we, on the south end, we're going to select that inner arc and bore that to the length of the sound chamber, as you see here, using that parameter. And then we're going to cut out that section in here. We're just going to do a short piece in here so that we can have this face right here to join our cutting tool to, or for the slow air chamber. Here I'm adding a plane to the top. I'm going to use that in a little while. I'm not using it right this second, but I've added, oh, wait a minute, I'm sorry, that's not the plane on top, that's the, oh yeah, it is. I've got both of them turned on. So I'm going to need that so that I can put my holes in, but I don't do that for a few more steps. So now, rather than just enable these, I'm going to actually do this part. I need my cutting tool to cut my slow air chamber, and I'm going to need a cutting tool to cut my sound hole. So I'm going to drag those in as components. Here's my slow air chamber. I'm going to get that out of the way here and say OK. And then I'm going to put a joint on it. I'm going to assemble joint, and on this one I'm going to select that bottom center right there, and I'm going to join it over here. I'm going to get the bottom center on this face right there, and that drops in there. Then I'm going to do a combine, the combine command. I'm going to select the flute as my target, and the tool body, I'm going to select that slow air chamber cutting tool. I'm going to choose a cut as my operation right here and say OK. And then I'm going to go turn off my cutting tool, and you can see that it's cut that in there real nice. I'm going to take a quick detour to that cutting tool and show you how I made this real quick. Let's back up here, turn on our sketches. I basically just drew my sound hole here. The way I wanted it. I put in, these are control point splines with just one control point that I've made vertical and horizontal to create this nice arch that is set to the wall thickness that it needs to cut through, with a reverse one on the other side. Same thing. I've set this width, the sound hole length. I've set the top part of this, not counting the curve, but just the top part is set to the sound hole length. And then I set each side of the arc to be 1/2 the sound hole length. This is really just aesthetics. It's really how I wanted it to be. I want it, you want air to travel smoothly through this. So, I put on, this started as a rectangle, and I used the fillet tool to put on these edges, and then I used a control point spline here to create this nice curve that I'll show you over here. That's this curve right here, so that the air flows nice and smooth through here. Okay. But you get this picture here, you can freeze it and you can see what all the constraints are. You can't see coincidences, but they're anywhere there's a black dot, there's coincident constraints. You can see where I've used tangencies to create nice smooth turns. So finish that, and then the next sketch is the end, which is going to mirror the it's basically the same as the south end of the flute, to be able to cut this out. So next thing I'm going to do is I'm going to start extruding. So I'm going to start extruding by extruding this surface for half the overall width. Overall width divided by 2. Then I'm going to shape that by extruding. I'm going to cut out the end down here. I'm cutting out this and this and this so that it'll fit nicely down into that slow air chamber where I want it to go. Then I'm going to extrude up the exit hole right here. And then I need to get this all smoothed out. I don't want this gap in here. I need to fill this in, and I need to create a nice transition here. So my first sketch will be right here. I did a projection on this curve. I did a projection on this line up here, and then I drew a let's bring up the sketch so you can see. Oh, it is up. I don't see the constraints here. They're not turned off, are they? Well, this is a 90 degree. It should probably have a constraint there, but like that. To make it straight up and down. Same here. Not sure why this one's not constrained, but I'm not going to worry about it. So that creates that. And then we finish that, and we're going to extrude that in. And this extrusion is a extent type of awl, and it's flipped. So it will extrude to the far side of this body, and I've got it set as a join. So now you see that's filled in there. But now I still want this to transition smoothly into here. So I got one more sketch here, which is parallel and coincidentally constrained to this line here that's projected in. And then from here I put a line up to here, up that is coincident to the end of that arc of that, which is a control point spline, and another line down here to close it up so that I can extrude this. This half an inch is arbitrary. It could be an inch, it could be whatever, but I felt like an inch was enough, or half an inch was enough. So once I'm done with that, then I'm going to extrude that again with an extent type of awl. Finish sketch. Come on, get out of there. You're bugging me. I'm not sure what's going on here. It's not letting me finish the sketch. There. Stupid notifications. Okay, now I extruded that. It's a join with an extent type of awl, so it's going to extrude it to the far side of this body again. And so that creates a smoother transition for the air to flow up and out of that hole. Okay, which you can now see over here. So here, so you can make that longer if you wanted to. I haven't played too much with it yet. I'm not sure how much effect it's going to have beyond this. So now we've got that cut out. We need to cut out the sound hole here. So again, we're going to drag in our sound hole that we've created. We'll go make that in a minute here, but we'll drag it in here as a component. It's dropped it over here. We're going to take it down here and put it here. And then we're going to create a joint. This one's awkwardly shaped, so we got to do it a little bit differently to get what we want. But what I want is the center of that arc, which is, I think, right there. And then the other side of it, let's get this down here, turn you up here. Now we're going to take the center of this face right here, and that didn't work. I got something wrong. Let's try it right there. Oh, come on. I must have it wrong on this face. Let's cut this one out, and again, let's choose right there. And right there. There we go. These joints are tricky. I don't know if you've never worked with them. They're tricky. Okay, so we've got that sitting in there now, and now we're going to do another combine. We're going to select the flute as our target, and we're going to select that cutting as our cutting tool. And we're going to make this a cut and say OK, and then turn off the cutting tool. And there we go. So now we have our flute pretty much all set up. We need to define our flue still. So I'm going to delete real quick the existing right there. And so our next drawing is, actually we're going to go do those finger holes now. So this is on that plane we defined back here that is the top of the, right there, the top of the flute. And here we're going to use all of those parameters we defined for hole diameters 1 through 6 and hole locations 1 through 6 to constrain our holes. This is not used, it's just there for my reference. I like to know where the center is between the north end of the sound hole and the south end of the flute. And that tells me where the center is. It gives me a general idea of how my holes are in relationship to the body. I want it to fall somewhere between the third and fourth holes here, but it's really not needed. It's just for my visual reference. So then I'm going to place a hole, 6 holes, and I'm going to constrain them with my, I'm going to constrain the center to this bottom line that I've projected in. So I've projected in the bottom contour of the flute, and I'm going to constrain those 6 holes with a coincidence to that line. And then I'm going to further constrain them by their hole location and their hole diameter. So like hole 1 location, hole 1 diameter. And I'm going to do that for each hole. Hole 1, hole 2, hole 3, hole 4, 5, 6. Okay, and then we're going to extrude those holes. We're going to cut them. It's disabled. Let's unsuppress that. And you can see I've got my holes there. We can turn off the sketch so you can see better. And then the last thing to do is to put in our flue over here. So I've set that here, and I've given the flue a length of the flue length, but I've added on the sound hole length to get it past the edge of this hole here. I wanted to make sure I got a clean cut on that. And it's constrained to half the width of the sound hole width. Half because, again, we're modeling only half of the flute. The other constraint is its location. So it's from the north end of the flute to the north end of the sound hole is our flue location. It's as you see here, blowhole length plus the slow air chamber length plus the flue length gives us our location. I think that's that on that. And the last thing to do is to extrude that, which is a cut. Just a simple cut that is the negative flue depth. Okay, and that's it. Oh no, one last thing we need to do is put the taper on the end. Next thing I've got here is a plane that is again on the top of the flute, and I will explain that in a minute. Right now it's set to 0, and like I said, I'll explain in a minute why I did that. So in order to put on the cone, I need to do a mirror. So I've done this mirror. What's my plane? Well, it's just the face of this thing, so I'll clear them so you can see what I did. So I'm going to mirror this body, and the plane is this surface right here. And I'm going to do a join. It could be whatever. So now I have my flute put together. And it has to be put together to put that cone on to cut the end here. So now I'm going to bring in my cone. And again, I'm going to do a joint and join it to that end right there and just put it on there. I'm not going to go through that whole joint again. But it's sitting on there, and I'm going to do a combine again with a cut. Okay. With the flute my body, cutting tool is the cone, and okay, and then I'm going to turn off the cutting tool, and we've got our tapered end. Um, let's jump over and make that cone real quick so you can see how I did that. Let's bring that up. Okay, so this is the cone. Let's back up our timeline and start with our first sketch. Our first sketch is just a circle that is defined as the blowhole diameter plus the wall thickness. So that defines this end of what we want left of the flute, which is the blowhole plus the total wall thickness all the way around. So times 2 for each side. Okay. Finish that sketch. Then we're going to create a plane, an offset plane that is our mouth taper distance. That's a variable I've defined in here. Our mouth taper distance. That's how far we want it to taper from the end to where it joins into the rest of the body. And I've just set that in an inch. I think that looks good to me, but it can be whatever. So that's offset 1 inch from the circle that we created. We're going to do another sketch to create another circle on this side, which is going to be our overall width. Okay, so once we have those 2 circles, we're going to do a loft. Oops, the bodies are off. To create this cone, which is going to become our cutting tool. Okay, so we've got one body here, which is the cutting tool. Then we're going to extrude the larger of those 2 circles out to make a cylinder. And it's going to be a new body. We want 2 separate bodies here, so we can use one as a cutting and the other one will be what's left, which will be our cutting tool for the next step. So we extruded that mouth taper distance, again negative in this case, to get it to go back the other direction. So now we have 2 bodies. We have the inner, we have the cylinder, and we have the cone. So now we're going to do a combine. We're going to select the cylinder as our target, and we're going to select the cone as our cutting tool, and we're going to set this to cut. We're going to keep tools turned off, and that way it'll just get rid of the inner one once it's done. So we hit enter. You see that other body disappeared, and what's left is our cutting tool. So it's got that cone shape cut out on the inside. Okay, so that's that. Our flute is complete. We're ready to start machining. So the first thing we want to machine is the inside. And I use 2 different approaches to this. The one I like the most right now is to use 1 piece of stock that is 1 1/4 inches square, at least for this particular model. And cut that down the middle. That way, it folds apart. You cut out the inside. When you fold it back, it still looks like it was cut out of the same piece of wood. If that makes sense. And to be clear on that, the stock needs to be 1 1/4 inches tall and 1 1/4 inches wide plus your blade width. I use my resaw bandsaw because it has the thinnest blade rather than my table saw, which has a much wider blade. The thinner that kerf is, the more it will look like it belongs together. The bigger a chunk you cut out, the less likely your grain is going to match up. This one, I don't know if you can even see that in the camera, but this one was cut that way. And if you can see it, you probably can't, but if you can see it, you can see that well, here, let me bring up this picture. Yeah, it looks like it came out the same. The grain matches up pretty closely because it just has that thin kerf from the bandsaw, from the resaw bandsaw. But the other approach is to use one flat blank that's like 2 or 3 inch, well, it's got to be 2.5 plus whatever width, so let's say almost 3 inches wide. Cut out the insides and then cut those two pieces and put them together. But then it looks, I'm not saying it looks bad, but it is two separate pieces of wood with different grains glued together. So I'm going to back up to that plane that we defined and explain that this plane will determine. First, I'm going to unsuppress. I'm going to turn that off, and I'm going to turn on this mirror, which puts two of them side by side. Now, if I've used a single piece of stock and cut it down the middle and folded them apart, I'm going to do it this way, where I'm going to put these two pieces together on the CNC, butt it up tight to each other, and let it carve out this inside just as it looks there on your screen. But if I'm using a single blank, I need to be able to cut those two pieces out after it's done carving. So I need a gap in the middle that my cutting tool can use to cut these two pieces out. And that, that's arbitrary. It could be an 1/8 inch bit flat end mill, a 1/4 inch flat end mill, or it could be a 3/8 inch flat mill. It doesn't matter. What matters is that you create enough space between these to allow that bit to cut them out. So if I'm using a 1/4 inch flat end mill to cut them out, I'm going to make a space in between these two of, say, 3/8 of an inch to give it plenty of room to work. So I put 3/8 in here, and now it's separated. So when it cuts out of this single stock, go over to manufacturer so you can see what I'm talking about, and we'll go to the setup for the inside cut. And I've got two bodies selected here, so you see my stock is that, which is 3 1/4 inches wide. And then I'll have a contour which will use a 1/4 inch bit to cut out each one of these after it's done carving the inside. Okay, I may be making that sound more complicated than it is, but I'm going to go back to design because I'm going to work on the assumption we're using one block that we've cut down the middle, and we're going to glue that together. So I'm going to set this to 0 to butt them up against each other to put them on the CNC. I hope that makes sense. Now, to cut the inside, the first thing we got to do is make some adjustments here, because we only want to when we do a morse spiral to cut these insides out, it's going to cut everything it sees, including these holes and including the flue. And we don't want it to cut those right now. I want to cut those when I'm doing the top, because I get cleaner cuts on them that way. So I need to hide these so that it doesn't try to cut them. So I'm going to go turn off the holes. I'm going to do a suppress features on that extrusion, suppress the holes. I'm going to do the same thing for this. I'm going to go to the extrusion for the flue, and I'm going to suppress features there. And now I've got a picture of what I want on here. And because the mirror that I've chosen here is the side-by-side, it also disabled the cone on the end, which is fine. We'll cut that out when we do the top and the bottom as well. We don't want it to cut those in quite yet. Okay, I hope that makes sense. Let's go to manufacture. I've already been in setup. I've got 4 setups here. I've got the inside carve I'm going to do. I've got the top I'm going to carve. I've got the bottom that I'm going to carve. And then if I'm doing inlays, I'm going to create the inlay pieces, which I use the flute to create those pieces. I won't get into that here. I deliberately left the inlays out to reduce the complexity. So to carve the inside, I already showed you, I need to make sure both my bodies are selected. By default, it's probably going to come up here and it's only going to have the one body selected. So you need to make sure it's got both pieces. I set my flute to be, so my y-axis is the long end of the flute. So I choose a box point on the top left corner. We know this is a certain height. We know it's 5/8, 0.625 inches. So we could set it to the bottom and let it, make sure that we've got a correct height on this. I'm not doing that on these. I know I'm setting my stock up to be perfect using my thickness planer. So I know these are 5/8. And by setting it to the top of the stock, I just feel more confident in this case doing that. So my X is on the short side, my Y is on the side, and my Z is up. And you got to screw around with these to get it right, and it takes some shuffling sometimes. Stock I set to relative stock size with no additional stock. So the stock I put on the table is exactly the dimensions of the final part. The only other thing I set in here is I give it a name, so that when I do my post-processing, that name comes up as its default name. And then for the inside, the only thing I'm doing in this case is a morph spiral. And the only thing I set in here is my bit. I choose a tapered mill, and I use a 1/8 inch tapered mill. You can see that right here. I get really good results with this. I really like this bit. It works well. You could use a 1/8 inch ball end as well. That's that. So that's it. I don't change any of the parameters that come up with this. These are all set according to the tool. The tool I use is from Spee Tools. It's a reasonably priced. They've worked really well for me, so I keep going back. The geometry, I don't change anything. Its default is silhouette, so it's going to do the whole thing. You could go in here and try to set so that it carves only these and leaves the tops alone. If you don't, then it's gonna run over the tops of these and make sure that they're flat. It's up to you how you set it up. But I don't change anything else. I leave everything to the defaults, which is no stock to leave, no multiple depths, or anything like that. And click OK. I do find with this bit that with a more spiral, it's going to go full depth on these cuts. So it's going to come down here and it's going to cut that first one all the way down to the bottom. So on that one, I leave it at the default speeds. But after that first cut, when it's only cutting on the sides, I speed it up to at least 150%, if that makes sense. So that's it. I'm not going to run through the simulate. Well, I guess I will, and I'll fast forward it when it does. But you see on the time, it's about an hour and a half to carve this, but it actually takes a lot less because, like I said, I bump up the speed once it makes that first cut. Let's just run through, carve it out. And everything looks good there, so we're happy. So we'll go ahead and send this to the post processor. All right, so now we got that carved out. Now it's going to come off the machine, and we're going to go glue it together. And it's still square stock at this point. It's not rounded off. Okay, so it's still at this point it's 2 boards, 5/8 inch thick, each carved out on the inside, and we're going to glue them together to make a 1 1/4 inch square tube. So we're going to go back to design. We're going to turn off that mirror, suppress it, and we're going to turn on the mirror that mirrors it the other way. unsuppressed to make our completed flute. Now, I want it not to dive into these two holes when it does that. And actually, I like to carve my holes separately as well. So, try to explain this. If I leave this hollow inside, when I've got the holes, let me turn on the holes. Okay, so I've turned on my holes, and I've turned on I'll turn on my my flue. Okay. If I leave this hollow inside, when it tries to drill these holes, it dives all the way to the bottom of this. So I like to come and unsuppress. Which one is it? This one. I want to unsuppress that so that it's no longer hollow inside. Now, when it drills these holes, it will only drill to the bottom of what I did my extrude to. Okay? So that's the first thing, is turn off the extrude for the inside here. Then I also don't want it diving into these holes. And you'll notice that the sound hole went away. That's because that extrude is now all the way through there. But this one's still open, and I don't want it diving in here. I've already carved this hole, so I don't want it messing with it. I don't want it to touch it. So I'm also going to turn off that cutting tool that I had there. I'm going to suppress this component that I pulled in, and that'll automatically suppress the join and the cut. Okay, so I'm going to suppress that, so that hole goes away. And I don't want it to drill the holes right now. I want to drill them separately, so I'm going to suppress the holes as well. So when I cut the top, this is all it's going to cut. Okay. Now, I used to drill the holes after I carved the top, but I've changed that and I've started cutting them beforehand, because then when it cuts the contour on the top, it kind of smooths those out. So for the moment, I'm going to turn back on my holes. I'm going to go over to design, over to manufacture, and I've got my setup for the top. And in my setup for the top, I have 3 cuts. I have the holes, the inlay, and the shape. And we don't have the inlay on this one, so we're not going to use that. We're going to use the shape and the holes. So the first one I'm going to do is the holes. I use a morph spiral for this as well. You could use whatever you want. You could use a 2D contour for, or whatever. But this has been working for me. It comes out perfectly tuned, so I'm not messing with it. Again, I'm using my tapered end mill. Excuse me. 1/8 tapered end mill. Right here. And for and I'm not changing any of the feeds and speeds here. I use a selection, and I select each of the holes, and I leave them closed chain, so I'm not changing anything. I do tool inside. That's important. You want it to cut inside. You don't want to make the hole bigger than what it's supposed to be. So make sure you've got that set to tool inside with no additional offset. And I don't change anything else in here. Should be no stock to leave, no multiple depths. Okay. I didn't go into the setup in this. Let's go into the setup. Again here, our body, our mirror must have been a join, because it's only showing one body here, so that's fine. If you did your mirror and said new body, this would be 2 pieces, and you'd have to make sure both were selected for your model. But our stock looks good. Okay. And again, my stock, I've set my stock point to the top left corner, with my X going on the short side and my Y going on the long side. Again, relative stock size, no additional stock. And I give it a name, G Flute Top. Okay. So Yeah, it's telling me it doesn't need to regenerate them, so that's fine. It doesn't need to. So there's our cuts for our holes. We can do that. Of course, the holes go very quickly. It takes only less than a minute to cut them. Exit the simulation. Now we're ready to cut the rest of the top. So we'll go back to design, and we'll turn off the holes. And you can cut the holes in the same as the other if you like. I just feel like I want a little more control over that. So it's cut it into, so now we go back to manufacture again, and this time we're going to go into another more spiral, which is the top. Again, we're using that same tool, the 1/8 inch tapered end mill. Same thing here. This time it's just silhouette though. We're not going to select anything. We're just going to let it cut this top. And boy, it's important you get this lined up on the CNC straight. Otherwise, you're not going to get a perfect, cut on your thing. It's got to be absolutely straight. And didn't change anything in here. Basically, it's just selected my tool and left the defaults. So we'll let that generate here for a second. Okay, and now this takes about 49 minutes, it says, but again, I'm probably going to up the speed considerably. This is an easy cut because it starts down the middle where it hardly does any cut, and then it just works sideways, back and forth, sideways, around and around and around. So it's only taking off a little bit at a time, going all the way around. So you can speed it up quite a bit. I'm going to speed it up to at least 150%. And we'll let it do its cut. That's it. We don't have these inlays here. I'm not even sure why it's showing them. Probably because this isn't suppressed. Now it will leave these knobs on the end, and I cut those off, or I put it on my belt sander, and I kind of smooth this out for the next step. Okay. All right. So now we're going to go back to. Actually, we don't need to go to design. Now we've got our bottom to do. Now for the bottom, because we've rounded off the top, this is where we now need our fixture to mount this into so that it holds it straight. So let's get into that next. All right, so here's our flute fixture. So this is really easy and quick to create. You'll have to play with it a little bit to make sure it is big enough to hold. But let's just real quickly, all I do is I drag in a flute as a, and what I've done is I've created a dummy flute. You don't have to, but you do have to make sure you turn off everything. So in my dummy flute, I've turned off all the extrusions so that all that's left is the outside contour with the nose cone, with this taper, and the nest, and nothing else, including a solid body inside everywhere. It's got to be solid everywhere. Otherwise, when it cuts, it'll leave those holes that are inside will become solid pieces in the new piece. Don't know if that makes sense, but let me bring up my dummy flute so you can see how scaled down it is. It's just a solid tube with the nest on it and with the taper on the end. And you can figure out how to do that with your flute. You don't necessarily have to create a new flute like I did. You just need to go turn off everything in an existing flute, suppress all the features that have any internal extrusions, cuts, so that all you have is this, including taking out, you need to make sure that the flue is gone, so just a very basic shape. And then once you have that, you're going to draw a rectangle around it. And I like to use whatever the width of my flute is, which is 1.25, and I add 1 inch to each side, so I end up with 3.25 as my width. I want this to be 1 inch because it's easy on my CNC to adjust my zero, my work zero, which is already set to where I'm going to lock it in. So now all I have to do is go tell it when I send it to work zero, and then I tell it that it's actually -1. So I set my X to -1, and then tell it to go to work zero again, and it should go over exactly 1 inch and be lined up perfectly to cut this. Because of this tapered end, it's a little difficult to set your XY with your probe tool, if that makes sense. Okay, so we have this, these notifications. We have that rectangle. Let's turn on the sketch so we can see it. And we're going to do an extrusion, a symmetric extrusion in each direction. And we're going to make it, in each direction we're going to go half the overall width. I didn't specify that way here, but just to be clear, it's overall. Oh, I'm sorry, I don't have any parameters in this, so that's why I just specified it. But I know what it is, so I just set it to be 5/8 in each direction. That creates 5/8 under the flute for the bed of the fixture, and 5/8 is half the width of the flute on top. Okay? And that's a new body, by the way. Make sure that's a new body, because we're gonna use the flute to cut into it, so they need to be separate bodies. Then we're gonna do the combine that we've done so many times already, selecting the box, or the new extrusion as our target, and our body is the flute. Set this to cut. Say okay, then come over here and turn off the component, the flute that we dragged in, and there you have it. And you're just going to do a Morse spiral on this. I'm going to go to manufacture. We're going to do our setup. Again, make sure that you set your box point, your stock point, to the upper left corner or wherever it is that you've been working from. Your stock, again, is relative with no additional stock. Post-process, I give it a name, flute fixture, blah, blah, blah. 7/8 in this case. Okay, and then we're going to do a Morse spiral. But this one we're going to do, we only want it to cut the inside. We don't want it to mess around wasting time on this, because this surface means nothing to us. So we're going to do a selection, and we're going to do a close chain. This can be tricky, so when I try to select it, you see how it gives me this outside edge? So I have to go into edit, and I have to tell it that I want this, and then it eliminates that and makes it just the inside. Okay, in this case I'm going to say tool outside, and you might think that should be tool inside, but I find that my flute doesn't fit in, so. And you might have to tweak this, you might have to play with this, you might have to add some additional offset, or go over here and add some stock to leave. So once you carve this out, test fit a flute in it. And if it doesn't fit down in there, it's got to fit in there. It's got to fit in there snug. If it's loose, it's going to move. It's not going to be. You're not going to get your perfect contour cut out because it might be rocked to one side or the other. So you need a good snug fit here. And so you might have to fool around with these two, either stock to leave or over here additional offset, until you get it to where a flute fits in it nice and snug. I like mine to where I have to actually kind of use a mallet and kind of tap it down into place. And then I use a couple of other things I cobbled together to help hold it down. But that'll be in the next part. Okay, so we've got that. And you can cut that out. So we've got our fixture. Don't save anything. Let's get rid of this too. Don't save anything. Or cancel and do save this one because I made some changes. Go away. Okay. So now we're ready to do the bottom. We really don't need to change anything. We're here. We're just going to roll it over, and all it's really going to do is just cut that round contour over it. So on our bottom setup, again, we want to go make sure that the body is both pieces. And like I said, if we did a join when we did the mirror, then it's just going to be that one block. You want to make sure you set your box point to the bottom side with the Z pointing away from the bottom or up. That should make sense. Same things on the relative size, no additional stock, and give it a name. Flute bottom. And like everything else in this, it's another more spiral. So again, all you're going to do on this one is select your tool. Again, it's the tapered 1/8 inch is what I'm using. It could be an 1/8 inch ball mill. Probably the only two real choices I would use for most of this. And then you don't select anything else. You stay with the defaults. It's silhouette and tool centered, and don't change anything else in here, and let it go. It's going to take about the same amount of time. It's going to come out at like 45 minutes, 46 minutes, but you can speed it up on the machine, and or you can change it if you want in the feeds and speeds on the toolpath. So that's it. Next, we're going to meet out in the shop, and we're going to make this thing. So look forward to seeing you then. Hope you enjoyed this. I hope it was useful. And we'll see you out in the shop.